Start here in a few minutes. A little bit over, I think. This way. Okay. All right, we're going to give about another 2 minutes before we get started, but let me see. Is there a kit next to? How do we give you one of these? Here you go. Have some rocks. Okay. All right. So, did everybody watch the video that I posted? Neat. Did everybody comment on the thing? Okay. So, I'm going to try and incentivize my lab update videos because that thing was chock full of information. If you have watched my lab video, my lab update video, that was probably the single most important update that I have posted. If you comment on it, I'm going to give you a bonus point for it. It's that simple. Like, if I have a lab update and you comment on it, there's going to be a bonus point involved. So, yes?
On the Canvas announcement itself? Or
the Canvas announcement itself, yes. I need to know that my information is reaching the class. Because while there's a lot of information on there, there's also information about the study session for this weekend. That session is something that I feel would be beneficial to every student in our class. Absolutely. I went through, I'll say if you watched it, you saw that I went through like, I think 4 or 5 points about class, about some things that I wanted to touch on. And I really do need you all to watch that. It's very important, and we'll answer a lot of questions that I've been getting in emails. That's actually why I need it. Was because I'm getting some emails, and again, I see some in the comments too. Canvas is an imperfect system for getting a hold of me because what it does is I'm not the only person who is listed in the class, right? So it's like Dr. Martin, myself, and another GTA who helps me grade stuff. And so it means that if I am messaged through Canvas, 90% of the time it won't go to me, which is why I have the other email set up. So be sure that if you want to get a hold of me, the email that I have on the syllabus and the one that I have listed there in most of the updates is the absolutely most successful way to get a hold of me because Canvas usually does not notify me that you're trying to get a hold of me. I know for a fact that there have been some of you students, maybe some of you watching, that have tried to get a hold of me unsuccessfully. I was informed maybe a week ago there was a student who was trying to get a hold of me for 2 weeks. I had no idea. Absolutely none. I had no clue because Canvas did not tell me. And Dr. Martin was kind enough to be like, hey, Mr. King, maybe you should go check this out. And I was like, well, I didn't see it. So there is an email. I've been trying to push this since the beginning. Email me at the one that I have on the syllabus, thegeohistorian@gmail.com, please. And go watch that lab update video. So do that. It's important. And again, okay. So next week is your midterm. Next week's midterm. Let's talk about this real quick. Yeah, that sucks. I know. The midterm is going to be as easy as I can make it. I mean, 95% chance here that it's going to be completely online. There is a very good chance, given the need for an online component, that I'm going to do my best to try and make the entire midterm be able to be taken online. This is a little bit tough when it comes to identifying rock samples. That does make things very difficult. And that is a part of the course that is, I can't cut that out. I can't cut that out of the course. So I will be doing my best to choose samples that will be most easily identifiable. In addition, in the video, I talked about Lab 5. Lab 5, there's a video that I will be posting. I want to do that after today because this lab, the lab we're doing today, and Lab 5 go together very well. And Lab 5 will be due by the midterm. I mentioned that in the video. I think it's like the 13th or something. Please, please, please try and get it to me beforehand, only because I'll be grading midterms. And if I have a bunch of labs to make up, that's just going to be a lot. Have mercy upon my soul, as I'm also a student, and man, it'd be a lot sometimes. Okay. All right. So with that out of the way, talked about the study session coming up. Watch the video. You comment on the video after watching them. Your bonus point. I'm going to add something into that because I may make you answer a question to make sure that you watched it. So you're sort of like, hey, I watched it, and like a code word in there or something. Oh no, it might say like a really funny word somewhere. Be like, what was the strange thing I said? Anyway, all right. Turn to your lab annuals and turn to page 60. Turn to page 60. Okay. All right. So this week we talked about heading into this week. We talked about igneous rocks, right? Last week we got into igneous rocks. We got into rocks that are formed through the either the intrusion of magma or the cooling of intrusive magma or the cooling of extrusive lava. Okay. The lab you're going to do before the midterm is going to be on sedimentary rocks. There'll be will be a lecture posted for that, and I have made my best effort to try and make it as clear as possible. Okay, but today we're doing metamorphic rocks. Today we're doing metamorphic rocks, and so when we talk about where's my thing here? Metamorphic. So metamorphic. We talk about metamorphic rocks, we're talking about, and the important word here is morphic, right? For something to morph, it changes, it becomes something entirely different. I mean, this is something where a rock will go from being one way, and this is one of the this is a thing that can happen to both igneous and sedimentary rocks, where I can take a rock that exists and turn it into something else through two driving forces. I am going to drive this home over and over and over and over. I promise you, until the midterm, you will hear these two things said. Heat. Okay? Heat and pressure. Heat and pressure. Metamorphic rocks. I want you to associate metamorphic rocks, heat and pressure, heat and pressure, heat and pressure, every time. The moment you see this word, metamorphic, heat and pressure, that's the first thing you need to think about. Because that is how these rocks change. That is how these rocks go from being one way from like an igneous rock or a deposited sedimentary rock to a metamorphic rock. Because two forces have acted upon these rocks. Heat and pressure. Okay. So, let's talk about heat first. So, we talk about temperature changing rocks. So we talk about the igneous rocks. We know that molten material, magma and lava, is very hot, intensely hot liquid rock, right? But that is not always the case. It's not the only way to change a rock. Sometimes what will happen is if you apply heat, high heat, to a rock, it will break it down and it will change it into something completely entirely, not just molten material. Okay? So, we're on the middle of page 61 here. And basically it says that every mineral has a finite range of temperatures within the range it can exist. So, basically the way this happens is think of the range of temperatures with which we can exist, right? Now, on the cosmic scale, these are uncomfortably small. So, you're too cold, you basically will freeze, you become Iceman, right? If you're too hot, what does happen? I don't know. You become the Human Torch, right? So you're too hot, you become a different way. But if you're too cold, you become another. But for the range of temperatures for minerals, right? For a rock to be able to be handled, like if I were to pick up this piece of anthracite coal, this rock has cooled, right? So there's no way that this rock is going to change in this cooled state right now. I mean, you could weather it, but that's different. But I'm not talking through heat and pressure. But if I were to take this piece of anthracite coal, as we often do, and apply heat to it and burn it, it will change, right? Okay. Basically, what happens is molecules just fall apart and then rearrange into something else. Okay. But pressure. Pressure is an important one. Pressure is how you're going to tell me one metamorphic rock from the other. So in the sedimentary rock lab, you will see that we talk about something called foliation. Foliation. So a foliated rock is a rock that has layers, right? It's a foliated rock. Okay. So what will happen is occasionally you will find a rock. Let's take where's that big sample of phyllite I had? There's a big sample of phyllite right here. Okay. And this is the light colored rock outside of your box. And this sample of phyllite has foliations, which means that it has layers right here, right? See that? So it has layers as it goes, and if you were to break it, you would see, and let's go back to previous slide here, where we talked about fracture and cleavage, right? So when you have fracture, you have something that shatters, a rock that shatters. So this rock, when broken, well, that's surprisingly tough, actually, will foliate. It will cleave. You will get these even planes, right? It cleaves. Should have chosen a better sample for that. But here we go. So you will see that even though I have broken this rock, it still has even planes. Okay? So when something foliates, it has layers. Okay? All right. And I like the example in the lab manual here because what it talks about is when you take a jar of pennies, shake up that jar of pennies, and it's like chaos in there. They're all over the place, right? Whereas if you were to take that same jar and drop it onto a table, they pretty much all orient flat. So what force is being exerted upon those pennies? Drop it out flat, right? It's like if I were to take these markers, okay, and just drop them. What force is acting upon those when I drop them? Gravity. Force of gravity. That's what's happening here, right? Okay, so when you have material that keeps building up on top of other material, right? On top of other rock material, it presses down. The weight forces it downward, right? The force of gravity forces it downward, and it foliates. This is very important. Like heat, pressure, and then you get into foliation here in a minute. We'll talk more about that. Okay. So that is how you classify metamorphic rocks. Are they foliated or are they non-foliated? We're at the middle of page 62 right now. Are they foliated or are they non-foliated? That is how, when you do the lab for this, for lab 6, it is very important to know whether it is foliated or non-foliated. I can tell you that on the midterm, what you will need to know is not so much the exact name of the rock. That'd be nice if you knew that. That will help you. But what will help you most is knowing whether it is foliated or non-foliated. That's what I'll ask you. Most of the time, that's probably where the points will come from. Whether something's foliated or non-foliated. I'm not going to ask you about the metamorphic grade, but that is something we need to mention. The metamorphic grade, if you look on the top of page 63, so metamorphic grade is a bit like the chart that we saw for igneous rocks, right? And this is what I was talking about in the video. We talked about the extra credit, okay? And the extra credit is asking you to basically build a chart like this with the igneous rocks, right? But this chart in particular measures something different. It doesn't measure the size of the particles. It doesn't measure the composition of the lava. This measures the temperature at which the rock has metamorphosed and the protolith. So protolith meaning the original material, the parent material. Okay. All right. I will show you how to use that table as we go through the samples here. Okay, so open up your kits. Open up the kits in front of you. Those of you at home, I will be showing you the samples as we go. All right. Okay. So the first one we're going to talk about is number 39. Number 39. And this is one that each of you at some point in your lives have probably interacted with. This is slate. So it tells you that pressure has reoriented these tabular crystals to produce excellent rock cleavage, which means that when you break this rock, it breaks in planes. It'll break in planes. So those of you at home, try and get a good, right, this is slate. This is a reddish color. It's very dense. And you can see along some of the places where it has broken that there are flat planes. Okay. All right. So, top page 64. And phyllite. All right, so phyllite is this rock right here, the light-colored rock in front of you that was not in your box. And so it says that this is formed by the continued metamorphism of slate. And this tells you that slate contains microscopic crystals of clay. So as the temperature increases, these clays are transformed into much larger, although still visible, crystals of muscovite. So you don't have to worry too much about knowing that part. But it says as you turn it in the light, as you kind of like look at it and let the light catch it, you see that it's a little shiny. Kind of has like this mirror-like quality. That if it was probably, if you could like slice it real thin, you could probably see right through it. So, all right. Number 37. This is mica schist. Mica schist. So this one says that it is the continued metamorphosis of phyllite at ever higher temperatures and pressures. And it says it allows the crystals to grow larger. And you can now see the individual crystals. Let me show those of you at home. This thing right here is kind of strange looking, kind of scaly, very shiny. Okay. All right. Sample 36. Sample 36. This is nice. This is nice. That is what this is called. Nice. All right. So you see here that it has lines, right? And this is a foliated version of granite. Foliated version of granite. Okay. So it's, you know that the granite has, you can see it has different stuff in it. This has hornblende feldspar in it. But it has alternating light and dark layers. And yes, is the metamorphism of granite. So when you see that something is foliated, there's a hint here. When something is foliated, it's been metamorphosed through pressure. Heat may have been involved, but the primary driver here is pressure, right? When you see something that is non-foliated, heat is usually the primary driver. Heat and pressure generally go hand in hand with these, but certain ones will have more an effect upon a rock than another. So, all right, 38. Sample 38 in your box. This is quartzite. It's quartzite. So this is what happens when you apply very high temperatures to sandstone. So you'll see in the sedimentary video that we will talk about red sandstone. Here, let me show this to you. But also notice that this rock is not foliated. It's kind of jagged. Has some weird edges to it. Doesn't really seem very even at all. Okay? Which tells you that pressure was not the primary driver here. And it even says here in the book that high temperatures have kind of welded together the grains of sand. And it's incredibly dense. Incredibly dense. Okay. All right. Number 40. It's marble. Marble. This is marble. All right. So I am not from here, but I've been told that this is common in like Silicaga areas down there. It's a non-foliated rock composed of calcite. All right. And it originates from the metamorphism of limestone. Okay. So it says the temperature and pressures associated with metamorphism recrystallize the limestone, producing a uniform kind of creamy texture. So it gives it like a really neat kind of like dynamic look. Okay. All right. And the last one is the sample in front of you that is not in your box. It is the this like shiny black rock right here, right? This is anthracite coal. Anthracite coal. The non-foliated rock produced by the metamorphism of bituminous coal. Bituminous coal was number, I think 35 in your box. So you can kind of like put the two next to each other and see the difference between the two rocks, right? Where bituminous coal tends to be just a little bit lighter and not nearly as dense. Okay. All right. So that is what I have for you. Your lab will be number let's see, lab samples. And I'm going to take people at home through this as you guys try this out. Will be samples 36, 37, 38, 39, 40, and then this light colored rock right here, right? This will be rock A. Okay, and this dark colored rock in front of you, this will be rock lobster, because I can. Right. Okay. All right. So what you're going to do is flip into your lab on page 66. Because you have not done lab 5 yet. Parent rock will not be necessary for you to tell me. If you put it, that'd be awesome. As it's generally listed in the rock ID in the lab. You do not have to tell me the parent rock. But you must tell me whether it's foliated. You must tell me whether it's foliated. Also, when it says rock ID, tell me what the rock is. This is one that there are only 7 samples, and I will ask you to tell me what the rock actually is you must identify. All right. And additionally, the metamorphic grade. Go back to page 63 at the top, right? So page 63, the metamorphic grade, this is how this works. This is how I would do this. Take a minute, examine the rock. Figure out what it is. Look in the lab manual and use what you know about the rock. Is it foliated, so on and so forth. Does it have a creamy texture? Does it have a red texture? Identify it first. Then figure out whether it's foliated or non-foliated. And then go to the metamorphic grade table on the top of page 63. And you're going to say, let's say I gave you a sample of amphibolite, right? Amphibolite's the one in the middle tab there. And you would tell me the metamorphic grade that it's from basalt. You will tell me the protolith from basalt. Actually, that's fine. And it will also, you also tell me the temperature at which it metamorphoses, which is the medium grade, high grade for amphibolite. Okay. I'm not grading harshly here, so those of you at home, I'll be taking you through this here in a minute. So yes, do this, and what I would also like you to do, there are 7 of those, 2 on the back. When you're done, take a picture of it and send it to me. There's currently no active assignment on Canvas. Like I said before, me and Canvas don't really get along, so we're going to do a lot of this by email. All right. Okay, so samples 36, 37, 38, 39, 40. I know those of you here in class, you may have noticed that you have, yes, seen this? Use the tools at your disposal. Sadly, those of you at home, I will take you through this as best I can, but these are the tools at your disposal. Use everything you have, but you still have to give me the answers for the other stuff. So, all right, so let me start pointing this down towards, yeah. Think that'll work. Yeah, it's fine. So you know what? No, we're gonna turn it this way. Okay. Sorry if anybody gets motion sick. Apologize. Chair. Yeah.
Okay.
Yep. All right. All right, those of you at home, ready? To go through this, make sure everybody can see me okay. All right, let's actually get a little farther, closer to the rocks, less on me, more on the rocks. All right. All right. So this is sample 36. Sample 36. So note the texture and pay attention to how the colors interact with one another. See the gray and black crystals and how they align with one another. Okay. 36. Okay. I'm watching, by the way. If you have something you would like me to go back and look at one, you let me know. I can see what you say. 37. 37. This is second sample. It's 37. Note how the light kind of catches this one. Looks a little scaly is the word I'm looking for here. So do that. All right. Okay. All right. 38. 38. All right, here we go. 38. Notice the color will give a lot away here, as we'll look at the way that it breaks. Okay. All right. That's 38. Sample 39. Sample 39. I showed this one from the beginning of class. This is the first sample I showed. Note that this one, look at the way that one also breaks. Take note of that. All right. There you go. All right. 38. Oh, 39, sorry. 39. And 40. 40. This is 40. And this is something we can find a little locally. Additionally, it's kind of a creamy texture to it-ish. I always thought that was a strange way to define a rock, but okay. That's 40. Rock A. Rock A. This is Rock A. This is Rock A. All right. So look at the. Take note. Also take note of its sides. Yep. Okay. Okay. Rock lobster. All right. Rock lobster. All right. This is the last one. All right. Okay. All right. So for those of you at home, I want you to fill this out and take a picture of it and send it in to me, please. And do so at the email that I've provided in the comments there in the live chat. And I think that's all I have for you live streamers today. So, well, I see somebody here. Okay, so we're not, as I said before, we're not doing the parent rock. You don't have to fill that out, but it's the rock from which it was metamorphosed from, which you will probably figure that out, but because we haven't done the sedimentary rock lab together, I'm not going to ask you. It's not something I'm going to be taking points off if you don't know. So, and pay attention for the Lab 5 to go up this week. They do go hand in hand. Metamorphic and sedimentary are complementary to one another. So, I will explain this again. Metamorphic grade is on page 63, and you will top of page 63, and you will tell me the grade after identifying the rock. So, yep. Okay. Okay, so those were your samples, and I'm going to end this here. So if you need to, the live stream will be available, will be published as soon as I end it, and if you need to, you can go back through, and you can stop the video at certain places if you did not get a good glimpse of the rock. So good luck, and I will see you, those of you on live stream next week.